showed you my favorite picture of the satellites of Jupiter. And my favorite satellite of all the satellites, well, Io is really interesting. Io is full of volcanoes. Nothing interesting life-wise going on there. Ganymede and Callisto, you can kind of even see are old and ancient critters. Europa's weird. Europa is a place that I think we need to really be paying careful attention to and thinking about if there is a chance of understanding the origin of life at Europa. This is the picture you saw at the very beginning as you were walking in. Europa is crazy. It's ice, it's an icy shell, and it's got these cracks, full of cracks and weird things. Here's a close-up view. It's got these cracks that are always weirdly colored. It's got melty-looking things that have come up through there. We don't really understand how all these things happen. And it's got these one set of regions that I want to show, which is right in here. At this scale, just look at a jumble, but it's a red jumble of stuff. At a closer scale, I don't have it in color because this is a JPL mission, a Galileo mission that flew to Jupiter and took pictures of all of these. So it's just kind of true that anytime you see really good pictures of things in the solar system, probably it was a JPL spacecraft that flew there. This is my favorite picture. I have a lot of favorite pictures, apparently. This is, if you look really carefully, each of these little blocks looks like, you can imagine it's an iceberg that broke off, floated away, and then refroze. You can even see, here's one that's cracked in half. Here's one, you can actually, I did this once and I can't do it on the screen without getting in trouble. You can cut these out and re-put them together over here, but they basically all broke off this section, went out through here and refroze in through there. This really tells you that there's something going on that heats and there's water going on there. We now know that Europa is a shell of ice and a huge ocean of water underneath that shell of ice. In fact, there's so much water on Europa that if you take all the water on the Earth and put it into a little ball, it looks like that. If you take all the water on Europa, it's bigger. There's more water in the oceans of Europa than there is in the oceans of the Earth, which is really a staggering thing, if you think about it. So, really, what you would like to think about is what is going on at the bottom of this ocean. It's true that this is an ice shell. There's no life in the ice shell. There's no life making its way through the ice shell. But the bottom of this ocean could be a really fascinating place. If you look at the bottom of our oceans, and particularly where the plate tectonics is active, where places are spreading apart, you see these things, they're called white smokers. Hot water is coming in through here, minerals are coming in through here, nutrients that things can use are coming in through there, and when that happens, you get things like tube worms. This is at the very bottom of the ocean. Beautiful tube worms, unconnected to the photosynthesis happening above. You get little octopuses, which is astounding, and without a doubt my favorite. You get this guy. He's mad. This is the first light he's ever seen in his life. Someone just took a picture of him and he's mad. But you know what happens if you look at a place that's not where you're spreading apart? You know what it looks like? It looks like this. This is not the most interesting picture of the bottom of the ocean. This is boring. Most of the bottom of our ocean is incredibly boring, and nothing's going on there. And there is some life in there, but it's just dead. And we don't know which one of those is Europa. Is it vibrant at the bottom of the ocean? Is it dead? One of the ways we're trying to find out is understanding what the composition of the ocean is. We can't go there yet, but sometimes the water melts up through the surface in those places you saw and shows up here, turns red. Maybe it even sprays out like this. So if we can find these spots, it's a really interesting place to go. Here's Europa again. There's two sides. They're different colors. I'm sorry to say this is a little washed out, so you can't see it. If you could see it really well, there's a big yellow patch right here. This side of Europa, maybe not so interesting. It's getting bombarded by the volcanic stuff coming from Io, and so it's red, sulfur. I'm not going to tell you what's in the interior of Europa, but this patch right here, which is differently colored, it's that stuff where things have overturned. It's a really interesting place to go look. So we took a look at it with my third favorite telescope, the Hubble Space Telescope, to try to see what this patch was made of. The answer is that patch, which is clearly water ice with some stuff coming from the interior, that patch of material is salt. Like salt, table salt. Okay, sounds boring. I have this box here. You can hold up that. So this box of salt is literally standing right here, which we can taste later. Because you might say, okay, you said it was yellow. Salt is not yellow. We all know this, but salt becomes yellow if it is bombarded with radiation. And at Europa, it is one of the most intense radiation environments in the solar system. And that salt, if you just do a little bit of radiation, goes from this. I literally did this yesterday just for this experiment, just to show you. This is just regular salt. I irradiated it with gamma rays for 3-4 hours, and it turns this color, which is now what it looks like. You know. So anybody who wants, if you want to see what irradiated salt looks like, here it is. Also, just tastes like salt. You might think you shouldn't eat irradiated salt, but only because you shouldn't eat salt. It's actually perfectly fine. So now we know, okay, it's salt. Great. Is that interesting? It is interesting. You know, we're like, okay, the Earth's ocean has salt, big deal. But the Earth's ocean has salt because of all that interaction with the surface area and with the bottom. It's a good sign that something interesting is going on. Let me show you one more thing, which is I'll admit, this is my favorite telescope today. This is the James Webb Space Telescope, launched a little over a year ago. In December of last year, just this last December, we finally got to point it at Europa. Now, it's a big telescope, but it's still pretty far away, so you don't get really detailed images like you get from all these JPL missions that are going there. But we got one thing that was really cool. This is that same region that's yellow that has the salt in it, and this is a map of where there is carbon dioxide in the ice. The same region that's been resurfaced has salt, it has carbon dioxide, and that tells you, I have no idea what that tells you. But we're trying to find that. So here's, my students are in the lab. I hope they're in the lab right now. I'm gonna call after we get back. Make sure they're still in the lab, working hard. They're in the lab right now trying to understand what happens with ices, salts, carbon dioxide. I think it might be that you have organic material, bugs, who knows what, organic material in the ices getting irradiated, turning into carbon dioxide. It's a pretty exciting thing. JPL is sending another mission to Europa to really map this out in detail. It's going to launch in a couple of years, be there a couple of years later. It's going to be a very exciting mission from Clipper. But the real dream, I'm gonna end on this real dream. The real dream is a mission a little bit further in the future that goes something like this. You drop it off from here, it lands on the surface of Europa, because what I really want to know is what is actually happening inside the ocean of Europa. Find one of these cracks, you can see it's kind of red like we know it is, finds a smooth spot, lands right there, and how do you get to the bottom of the ocean? Well, you build your big thing here, you light a nuclear pile, and you start to just melt your way down. We do this in Antarctica for glaciers right now. We can do this now. There's a little tether for the radio system that goes there, and when you get into the ocean, your capsule opens up and spits out a tiny little submarine. The tiny little submarine we now have, these are being tested at JPL, little things like this that can be autonomous and fly around. You get to the bottom, you see things that are maybe like the bottom of the Earth, and maybe not, but on this particular case, you go around, you look enough, and you see these guys. Clearly, this is going to happen, right? We know this is true. This may not be true. But this is the hope, this is the dream. This is a few decades down the road. But I think understanding the ocean of Europa is really the key to understanding the origin of life in our solar system and planetary system. And I just want to end with one last thought, which is really, to me, it's how much fun this is to work on at a place like Caltech. A place like Caltech, it's a small place. You hear about it a lot because it has huge impact for such a small place. The benefit of being such a small place is that you get to interact with everybody. You just heard a talk from just the two of us that included sort of all these different things. Planets around other stars, Earth history, extreme environments, the bottom of the ocean, early Earth, evolution, origin of life. These things, in most places, they would be siloed into individual departments. people wouldn't talk to each other. At Caltech, we have lunch together. We have, you and Andrew Howard sit around and talk about little planets. We talk about all these other things. It's a fantastic place to do this. And to really make this happen, we have just in the recent past started what we call the Caltech Center for Comparative Planetary Evolution, which really does blend all of these different things into a set of scientists all trying to understand how planets put themselves together, how life emerged on Earth, why we're here. And I think this is something that's fascinated humans forever. But I think that actually we're going to answer these questions. I think these questions seemed unanswerable even 10 years ago. And I think if you just wait a few more years, we're going to actually finally know the answers to why we're actually here, like Constantine started at the beginning. So, thank you.